In this video we're gonna see about vector calculus. Okay, before we begin we need to be familiarized with certain stuff so it would be easier for us. Now in vector we have x, y and z, so each x, y and z will put a head on it, so we know that it's a vector. Okay, so x is for the x coordinate, y is for the y coordinate, and z is for the z coordinate. Now for this kind of question we have the a vector and also the b vector. Now the question asks us to add a and b together. Now we know and we notice that these are the x, these are the y, and this is z. Z doesn't have any pair, so x vector. Okay, before that you may write it behind or in front depending on your comfortability, but the question suppose has it in front, you may also write the answer as it is behind. There are no certain rules, but if you want to follow the exact rule, just follow how the question has been written. Now for the x vector we know that 10 plus by 2, then sum y vector, this is -4, so -4 plus by 1, and then our z vector doesn't have any pair, so 6 plus by O. So the addition gives us that this is 12 and -4 plus 1 should be 3, so 3, and then this is 6. So this is how you do the addition. Okay, addition is quite simpler. Now for the next part we have point P, point Q, and this is point P, this is point Q, so the coordinate has been written as x, y, z. Okay, in this format. Now position vector for RP, you just need to translate this coordinate into vector. So RP is equivalent to x hat 0, so you don't need to write it, y hat 2 plus z hat 4. Okay, now for the RQ we know that it's x negative x3 plus by y only 1, then plus by z hat 5. Okay, now distance from P to Q, so it says P to Q, meaning RQ minus RP. Okay, if it says from P to Q, you need to take the second minus with the front. Now in this case we know that RQ minus with RP, so RQ minus with RP, we know that -3 minus by 0 nothing, so it's just 3 back, so 1 minus 2 become -1, so then 5 minus 1, it's just z. Okay, this is the answer for it. Now if Q to P, we know that RP minus RQ, so the other way around, or you just invert this and you'll get the answer. If you invert, you'll get x3 plus y z minus y hat minus z. Alright, now distance between P and Q, you can either take this or this, so this is how we write it. Then we square root the square of each, so -3 square plus, here either way it's 1 plus by 1, so you'll get 11. This is the distance. If it's saying from P to Q, you need to take the second one minus with the first one. If it's saying between P and Q, you either need to take the distance from either one and calculate it here as such. Okay, now for the next, before we begin the next part, we need to understand certain stuff. Okay, in the coordinate system we have 3 coordinates: Cartesian, spherical and cylindrical. So this is our reference coordinate position or axis. So our x-axis is always here, y-axis is always here, z-axis is always on top. Okay, now if we use this table, it's quite easier for us to translate. Okay, so in Cartesian we call it x, in spherical we'll call it theta, cylindrical also same. For y, in spherical we call it r, big R, in cylindrical we call it the small r. For Cartesian z we call it delta, I think, theta, theta, sorry, any omega, sorry, any word that you want to use. Cylindrical, it's z. Okay, so this is a simpler form of table that you can use. This is not the exact table, this is a simpler form of table that you may use. Okay, now before we continue, I need you guys to remember this two stuff too. Okay, so from a degree to radian, we need to times by pi over 180. For radian to degree, we need to times it by 180 over pi. And for differential and integration, for differential, from sine to cos, cos to negative sine to negative cos, and negative cos to sine back. For integration, it's the other way around. Okay, these two stuff is something that you need to remember for engineering, and I need to reflect it again. Now for the normal Cartesian that we use in our everyday life, we know that xyz is our normal coordinate system, but in cylindrical coordinate system we have the r, theta, and z. Okay, so what is r? As said, if you notice here, r is in the y position, so this is y, and we know that r is something that's nearer y. So the distance from the mid position to y is considered as r. Okay, so r is always in this direction. Okay, it's in the y direction. Now we notice that z is just the same. Okay, z is just the same. Z is just the height. Okay, z is just the height from the underneath. Now x is covered as theta, so it's theta. Okay, from its origin to where it's stopping. So x, theta, y is r, and z is just z. Okay, remember it. Now for the spherical coordinate system, we know that our x is still theta. If you notice here, it's still theta. Y is now r. Now what does r mean? R means radius, of course, but notice this. So our y now doesn't calculate in this area. Oh, sorry, it technically revolves around this. Okay, now then we have our z as theta. What does z as theta mean? Now z means, we know that z is here, so the from this tower, where does the coordinate stands? Okay, to clear you guys up, x is just the same theta. Okay, x is theta. Now the y holds the position, how long is it from the mid. Okay, it's technically radius. Now the what do you call it? Okay, delta, we name it delta. From z, where does the point is there? Okay, from z, the what angle of it. Okay, now this is the base of cylindrical and spherical. So this is something that you may use in order to find, they will give this, or you can refer it from the appendix even, but in order to find what is z, what is theta, you may use this, as you can find it. For example, in the spherical, we know that x is theta. Okay, we know x is theta, something like this. Then z is theta, so okay, maybe the point is here, so you know that. So the r is y. Okay, something that you can play along. Now then we have these tables. So this is to transform from Cartesian coordinate to cylindrical. From, is it the same? Yeah, it's just the same. So Cartesian to cylindrical, cylindrical to spherical, we have those kind of formulas to be playing with. And this is also the same. Okay, now this is something that we need to know. Okay, this is for the curls. Now before we continue, we just do a simple exercise. Now if we have our Cartesian coordinate, maybe we have 1, 2 and 2. So x, y, z. Now this is Cartesian. Now we need to change it to cylindrical. So we know that Cartesian to cylindrical uses this. R is x square plus y square. So you just take the x square plus y square, you plug it in the calculator, you'll get square root of 5. Same goes to the theta tangent, and you plug in the value, you'll get 1.107. Okay, please do remember, put your calculator in a radian angle input, not degree. Okay, make sure it's in R. Okay, then the z is just a normal z. Okay, now clear it up. Now we want to do the spherical. For spherical, Cartesian to spherical is here, so it's just the same. You plug in the value and you'll get the answer for R as 3, theta as 0.841, and also delta as 0.841. Actually delta is this, theta is this one is theta, I'm not sure. Then okay, maybe we have our cylindrical coordinate now as 2, 3, pi over 3 and -2. So this is R, this is the theta, this is z. Okay, using what do you say, using this stuffs, okay, we actually can identify the coordinate system. Just now I said that using this you can identify which is what, but in order to write in this format you actually can use this table as a hack. How? Cylindrical, if cylindrical, this should come first, this second, this third. If Cartesian, x first, y first, z. If spherical, R. Okay, you understand? For example, if I want to write as a spherical in a coordinate system, so I need to write R first, then I need to write theta first, then the theta. Okay, back to the original question. This is our cylindrical coordinate. Now from cylindrical to Cartesian we just use this. Okay, now from cylindrical to spherical, so cylindrical to spherical we use this. Cylindrical to Cartesian we use this. Okay, so we have cos and sin. Make sure you type it correctly in the calculator. For this Cartesian you will get 3, 3 and -2. For spherical you will get 4, -1 over 3 pi and pi over 3. Now let's do a calculation for this. Copy this. New page. Okay, so maybe we have our question as z, then we have y, then we have x. So maybe we have a round, so it's 3 centimeter in radius. Then we have a specific, maybe this is the area that is being covered. Okay, so the first is 30 degree, then the second was 60 degree. So the curve is something like this, so you need to find the surface area for it. Okay, so in order to find the surface area, this is the surface area what do you say, formula. Now we have 3 formula here. Okay, each formula represents a unique characteristic. In this case we know that the radius is not changed. Okay, the radius is same. This is a something that's looking like a globe, so it's 3 cm in radius. Now the problem here is that the first round above is 30 degree, the second round that's underneath is 60 degree. Okay, now the unchanged variable is R. Now we take the first one. Okay, so by taking this we notice that we need to write it as r hat r square sine and e, and then okay. Now we need to integrate this. So by integrating this, we will get as such. Okay, so by this we know that we need to integrate this first, then only this. Alright, now we can remove this. So r square, so our theta, okay, our theta as said is this and this because it's in the x. So we know that is 60 to 30. Now as said just now, degree to radian, we need to use pi over 180. So 60 degree is pi over 3 and 30 degree is pi over 6. Okay, this is the sorry, 30 was here, 60 was here. This was the 30 and 60, so it's calculating as such. By that, d theta is x, so we know that this specific shape here is 360 degree in x-axis. So 360 degree is equivalent to 2 pi. 2 pi, okay, so 2 pi, the underneath is 0 lah. Then this is for theta, we already finished, so we just write it. Now for the delta, now for delta we know that 30 to 60 degree, so 60 degree is pi over 3, 30 degree is pi over 6. Now the remaining is sine theta. Okay, this is the equation that need to be solved now. Now this is the original equation, we remove the variable outside. Now it became as such. We need to find this first, as we already find, then we need to find it. Okay, it's like a function that's in a function. Now r square, we know that r is 3 centimeter, 3 square is 9. Okay, now we just let 2 pi here. Sine theta, we need to integrate sine. As we know that sine is being integrated becomes negative cos. Sine integrate becomes negative cos. Okay, sine cos, negative sine cos, so integrate is as such, integrate goes high. So negative cos theta, we know that it's pi over 3 to pi over 6, then the remaining is for this lah. So if we input in calculator and we solve, we'll get as or you may have the simpler version, there's nothing wrong in it. Okay, then this, if we integrate, we technically just get this, it's like 1 integrate by dx, we'll get x. Okay, so 9 times by negative 1 2 or 3 2 times by this theta, which is 2 pi to 0. So technically 9 times by 2 pi times by, so this is the surface answer, but this is not the complete answer. You need to complete by doing the following exercises. Okay, now there is something I need to show. Okay, this is the stuff that we were talking just now. So it's 30, then it's 60, so x is always 360, which is equivalent to 2 pi, which is also the theta. So theta. Okay, now for the this one, you know that 60 to 30. Okay, now this is what I was blabbering just now. Now find the surface for the following. Now here we notice that r is unchanged, theta is being changed, z is not being changed. So for this we will take this. Okay, now we notice that dz, so z is 2 to negative 2, we have written it. Then inner part is this one, pi 3 to 0, pi 3 to 0 as said. Okay, as said, r we make it outside, and d theta, if we integrate we only get theta, and dz if we integrate we only get z. So this, and then we get z. If we times everything, we'll get 4 pi. In this case, r is the value that's not being changed, and these are the value being changed. If you find it, you'll get this. So as just now, r2 move out, d theta, theta's value is pi to 0, theta's value is pi 3 to 0, then you calculate. Okay, now for the final, x is being changed, y is not being changed, z is being changed, so we take this. Now notice here, if it's r hat and we have r, we put the r out. If it's r hat and r square, we put the r square out. Now in this case, we only have the hat, we don't have any y or dx in it, so this is how we write. So dz is 5 till -1, check. Dx 4 till 0, check. So dx, if we integrate, we only get x. Dz, if we integrate, we only get z. So if we calculate everything, we'll get as such. So this is how you complete the part 1 chapter for calculus, and thank you.